Yes. So in the last class, we were discussing about the pH scale. So we have covered pH scale, right? So we have a scale from 0 to 14, where your 7 pH is neutral, pH less than 7 is acidic, and pH greater than 7 is alkaline. So now we will learn about the universal indicator paper. Okay, we have a universal indicator paper which also tells us the acidity and alkalinity of a solution. So we can find the pH of any solution by using a universal indicator. What is the universal indicator? It is a mixture of dyes. For example, litmus. Litmus is what? It is a purple dye. It is a universal indicator. So litmus, it can be used as a solution. It can be used as a paper strip. Okay, its color changes with pH is shown here. For example, in pH 1, it changes to red. As I already told you that acids turn litmus red and bases turns litmus blue. So if you have a very acidic pH, so it turns your litmus red. If you have a very basic pH, it will turn your litmus paper to blue or violet. And if you have a pH of 7, then the litmus paper would be green. So you have to learn all these colors like red, then we have orange, then yellow, yellowish green, green, then greenish blue, and finally to blue. So this is your universal indicator paper, and the example of a universal indicator is your litmus. Is it clear? Okay. So a universal indicator, it is a solution or a paper strip that changes color over a wide range of pH values.
Good evening. I was delayed, ma'am. Sorry.
Yeah, good evening. How are you?
I'm fine, ma'am.
Okay. So in the last class, we have discussed about the pH paper, right? The pH 7 is neutral, pH less than 7 is acidic, and pH greater than 7 is alkaline. Now we are learning about the universal indicator paper. So universal indicator paper, it is actually a solution or it is a paper strip which changes color over a wide range of pH values. So it allows us for a general estimate for a solution's acidity or alkalinity. Okay, so it is a mixture of different indicators basically, and each is changing color within a specific pH range. So it can
Sorry,
be
ma'am. You
used
said within a specific.
sorry,
You said within a specific.
within a specific pH range.
Yes, ma'am. So
Okay, so
the further you go, the darker the color gets.
yes. For example, it starts from red, then it moves to orange, to yellowish green, to greenish blue, and finally to blue, and then to violet. If we increase the alkalinity of the solution. So it can be used as a solution, it can be used as a paper strip, and it is changing color over a wide range of a pH change. So this question is your homework for today. What does corrosive mean? How would you test a substance to see if it is acid? Write down the formula for sulfuric acid, nitric acid, calcium hydroxide, and ammonia solution. Yeah, so I think you can easily do these three questions. Corrosive means acid bases both are corrosive. How would you test a substance to see if it is an acid? So I have told you the way, and you have to write down the formula of these acids and bases.
Yes, ma'am. Let me copy it down.
Okay, next is acids produce hydrogen ions. So now let's come on to the chemical properties that acid produce hydrogen ions. Hydrogen chloride, it is a hydrogen chloride, it is an acid. It is made up of molecules. It is a gas which is made up of molecules, HCl gas. It dissolves in water to give hydrochloric acid. But this is not molecular. In water, the molecules break up or dissociate into ions. So if you take the aqueous HCl in water, then this HCl aqueous, it dissociates into ions and it gives H plus ions in the solution. So by that we can know that HCl is an acid. Why? Because it dissociates to give H plus ions in the solution. That's why it is an acid. So you have to remember that acids produce hydrogen ions in the solution. Okay.
Yes, ma'am. Ma'am.
Yes.
So since you said acids are hydrogen,
Yes.
is it hydrogen donors? No, hydrogen givers. I'm not sure which one it
Acids are
is.
hydrogen. Is also known as what? Proton, right? One proton, one hydrogen. Proton is also having one, right? So you can say that acids are proton donors.
So does that mean when it's a base, it takes the hydrogen?
Yes, bases are proton acceptors. So what is the difference between strong acids and the weak acids? So we have we have a strong acid that is HCl, and we have a weak acid that is CH3COOH, which is also known as your acetic acid. What is the difference between them? So strong acid, they dissociate completely 100% to give us H plus ions. Okay, they dissociate completely. All the molecules of hydrogen chloride, it have become ions. But in weak acids, only some of the molecules have become ions. So when acetic acid dissociate much less than 100%, so some of the molecules of this acid, ethanoic acid, it will dissociate into its ions. This is very important that in solutions of strong acids, all the molecules become ions, but in the solution of weak acids, only some do. So, which conduct better electricity? Weak acids or strong acids? Of course, strong acids conduct better. Why? Because there are more ions present, and ions are responsible for the conduction of electricity. They have a lower pH, right? Strong acids have lower pH as compared to weaker acids because they have more hydrogen ions present. So if hydrogen ion concentration increases, pH decreases. Okay, if hydrogen ion concentration increases, then your pH decreases. That means it becomes acidic. So the higher the concentration of hydrogen ions, the lower the pH. So you have to remember all these points.
Yes. Sorry, ma'am. Okay, I understand. It's fine.
So strong acid dissociates completely into its ions in a simpler words, and weak acid dissociates partially in the simpler words. Are you right?
Ma'am, I was
Okay.
writing.
And I
Can you
again
see me now?
yes, I can see you now. And yes, you
Okay.
are saying in the last class that you were sending me the picture of the question that you are finding difficulty with. I didn't receive any question.
Oh, yes, ma'am, I forgot. Let me look for the question now. Let me download the paper.
Okay. So if you have any doubts, then please let me know from this chapter. And if you are finding any difficulty in other chapter also, you can send me the picture of the question. Okay, so that in the next session I can take the question. So is this done? The difference between strong and weak acids?
Yes. I think I actually have the paper.
Sorry?
I think I have a paper with the question. Let me look.
Okay, so whichever question you are finding in difficulty with, you can send me the question. Next, we are reading about the alkalis. As we have studied that acids produce hydrogen ions, so alkalis produce hydroxide ions. Okay, so example, the best example of an alkali is sodium hydroxide. What are alkali? Alkalis are bases that dissolve in water, that are soluble in water. And the best example of this is sodium hydroxide. It is a strong base. That's why it completely 100% dissociates into Na plus and OH minus. Okay, so it contains hydroxide ions. OH minus ions are known as hydroxide ions. Okay, this is true for all the alkaline solution. Solutions of alkalis contain hydroxide ions or OH minus ions. So acids produce H plus ions and bases produce hydroxide ions. Copy it.
You said acids produce H plus ions and bases produce
Hydroxide ions, OH minus ions.
Yes, ma'am.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
So now, see, we have an alkali, sodium hydroxide is an alkali, NaOH, potassium hydroxide is an alkali, KOH, ammonia solution, NH3, it is an alkali. For a 0.1 molar solution, conductivity is given as 20, pH is given as 30, potassium hydroxide conductivity is given as 15, pH is given as 13. For ammonia, it is given as 0.5 and pH is given as 11.1. So can you tell me that what is conductivity?
Conductivity is the ability to let electricity pass through.
It is the ability to
Let electricity pass,
yes. So
for a substance to let electricity pass through.
yes. So in simpler words, it is the ability to conduct electricity. And this is micro. This S is the unit of conductivity. It is Siemens. So it is micro Siemens per centimeter. Okay. And this symbol is micro Siemens per centimeter. So this is the unit just. So sodium hydroxide conductivity is higher than potassium hydroxide, and ammonia solution conductivity is very lower. pH, you know what is pH. So sodium hydroxide and potassium hydroxide are strong alkali because their conductivity is higher, but 0.5, which is very, very lower. So it's a weak alkali. So we can see here that sodium hydroxide and potassium hydroxide show higher conductivity and have higher pH. They are strong alkalis, but in ammonia solution, they have lower conductivity and a lower pH. That's why it is a weak alkali. So you can differentiate on the basis of pH and the conductivity. So before doing this, let us solve the questions. So I'm writing a question here. Okay, so you have to answer that. I'm giving you options also. So question number 1 is that which statement. So Tino, you have the question. I'm writing it for Silathimba. Which statements help?
Sorry.
This question you have. Okay, I'm solving your question only. So I'm writing it for Silathimba. Explain why an increasing amount of carbon dioxide of carbon dioxide or methane in the atmosphere causes global warming. I'm writing GW. GW means global warming. The first statement is that carbon dioxide absorbs thermal energy from the earth. Thermal energy from the earth. Second statement is that methane does not absorb thermal energy. Does not absorb thermal energy from the sun. Third statement is carbon dioxide does not reflect thermal energy from sun to earth. And the fourth statement is that methane reflects thermal energy from earth back to earth. So you have to tell me that which statement help explain why an increasing amount of carbon dioxide or methane in the atmosphere it causes global warming. So option number A is 1 and 3. Option number B is 1 and 4. Option number C is 2 and 3. And option number D is 2 and 4. So yes, Elthema, read this question and try to answer this question. Which option should be correct? Then I will explain. Tino, you also try to read and analyze the question and give a guess so that I can explain.
The last one is methane reflects thermal heat from Earth back to Earth.
Yes. Which statements help explain why an increasing, as you know that carbon dioxide, methane, they both are greenhouse gases. So why an increasing amount of carbon dioxide and the atmosphere, methane in the atmosphere causes global warming? So first statement says that carbon dioxide absorbs thermal energy from the earth. Is it statement correct?
I think so.
Yes, it is correct. Carbon dioxide, it absorbs thermal energy from earth because carbon dioxide, it is a greenhouse gas. So it absorbs the radiations, it absorbs the infrared radiations which is emitted from the earth's surface. So it prevents it from escaping into the atmosphere, it prevents it from escaping into the space and thus warming the atmosphere. That's why the temperature is rising so much. So one statement is also correct. One statement is correct. So C option and D option we can discard. Second statement says that methane does not absorb thermal energy from the sun.
It's true.
No, it is not true. You have to tell which statement help explain why an increasing amount of carbon dioxide or methane in the atmosphere causes global warming. So 2 is not in the option, 1 and 3 and 1 and 4. So let us check the third and fourth statement only. Carbon dioxide does not reflect thermal energy from sun to earth and methane reflects thermal energy from earth back to earth.
I think the answer is B, ma'am.
What do you think, Sirathamba?
A.
You are saying that carbon dioxide does not reflect thermal energy from sun to earth. But it reflects. Carbon dioxide reflects thermal energy from the sun to the earth. That's why the temperature of the earth is increasing. So methane, it reflects thermal energy from earth back to earth. This statement is correct because methane is also a greenhouse gas and it absorbs and re-emits the thermal energy from the earth's surface, which contributes to the global warming. So the statement B is correct, 1 and 4. Okay. Carbon dioxide absorbs thermal energy from the earth. That's why the temperature of the earth is increasing. Methane, it reflects thermal energy from earth back to earth. That means it re-emits the radiations. Okay. So next question for you is, you have to answer this question, question number 2. The exhaust gases from cars contain oxides of nitrogen. How are these oxides of nitrogen formed? Option number A, nitrogen and oxygen from the air react together at high temperature in the engine.
Ma'am?
Yes.
I think when we're done with acids and bases, we should do chemistry of the environment.
Yes, they all are the questions of chemistry of the environment. That's why you are not able to solve this, right?
Yes, I've never done it.
Okay, we'll see. Because that is also important. Polymers is also very important. Nitrogen from the petrol reacts with oxygen at high temperature in the engine. And the D option is nitrogen reacts with oxygen from the air in the catalytic converter. So read all the options and the question carefully and try to solve this question. Although we haven't covered this chapter, but this is easy, so we can do this.
Ma'am, can I attempt?
Yes.
Is it D?
Nitrogen reacts with oxygen from air in the catalytic converter. C. Sridhar is saying C. How nitrogen comes from petrol? No, this is not correct. Nitrogen cannot come from petrol. It is saying the exhaust gases from cars contain oxides of nitrogen. How are these nitrogen oxides? How they are formed? Okay, so one student is saying A and one student is saying D. So yes, it is clear that B and C cannot be the answer. The answer should be A and D. So what should be the answer? Nitrogen and oxygen from air react together at high temperature in the engine. So very good. A option is the correct because nitrogen and oxygen from air, they react together at high temperature in the engine to form oxide of nitrogen. What happened in the catalytic converters? In the catalytic converters, your harmful gases, they are reduced to your non-harmful gases. For example, carbon monoxide is converted into CO2 and the oxides of nitrogen which are harmful, they are converted into N2. Okay, so this is not the correct answer. A option is correct answer, that nitrogen and oxygen from the air, they react together at high temperature in the engine to form oxide of nitrogen. Okay.